Hi everyone, and welcome in our last tutorial in this series of how to automate your ANSYS Fluent simulation inside PyFluent. In the last tutorial, we created the mesh using the polyhedral elements. In this tutorial, we'll be explaining how to set up your ANSYS case or ANSYS Fluent simulation. So let's start. As you can see here, we start by importing a few libraries. And the most important one here is the ANSYS Fluent one, or the PyFluent. This section is regarding submitting multiple or running multiple scripts in the same time. After a few iterations, I had to define these variables or these environments. I'm not very expert in this part, but you can try using them as is. And again, you will need to change this path so it will point towards your ANSYS installation. Next, we have our settings for the simulation or the running. The start geometry and the end one from 1 through 40. We have 5 profiles. The profile here is basically, you can think of it as a file that you are defining your transient boundary conditions. In our case, we have a transient velocity and transient concentration. I can show you this an example for the profile file. It's called profile1. This is the profile name. 3 here represent number of variables. 801 is the number of time steps. And 0 represent the periodic or non-periodic boundary conditions. If they are periodic, you can just like make it 1. We just made it 0 and defined the whole boundary conditions for all time steps. And one more thing worth mentioning here, from 0, this is the first time step, then we have 0.005, and any time step in between will be interpolated from these values. For more details about how to create your ANSYS profile, you can check YouTube, this tutorial for example. Going back to our script, this is the number of processors that you will be running your simulation on. We are using 16. We have this flag that will be used later to either activate the turbulence or making it laminar. In our case, it's laminar flow. Time step size used inside the simulation. Number of time steps, we have 4,000, which is equivalent to 4 seconds of total flow simulation. Max iteration per step. For each time step, you are iterating till convergence criteria you have, or the maximum number of iteration. Then we will be saving our results every 50 time steps. So per each second, we have 20 files. Now you need to define the name of your inlet boundary conditions or inlet label, which is blood inlet and blood outlet. And ANSYS Fluent by default, or sometimes they are naming the fluid zone as solid. We need to change the acting fluid from air to blood, and we will be defining the blood the properties as well. Here are the mesh folder and the results root, or the result folder will be writing our results to. We have the blood density and blood viscosity in CHC units. And then we'll be starting our main function. You define your mesh file. Here we are iterating over two things. We'll be iterating over two things, the geometry number and the profile number. So we are doing a few readings here for the files and folders. We do a few checks, basically for the mesh file and the profile file before start running. Then we start timing, or to check the time consumed during each simulation. First step is launching ANSYS or PyFluent. Here we are defining the precision. It can be single or double. Number of processors defined previously, which is 16, and this is the start timeout. Now, some general setup we used to do inside the Fluent. Pressure-based is the default solver for most of the cases, unless you are doing some compressible flow or density-based one. You keep it pressure-based, and your time is transient. First command we will be using is file.read case, which is reading the mesh file. And to get more like of these commands, you can go into the PyFluent GitHub. They have like a very great documented repo where you can check for different commands. Going back to our script, we are defining our solver, which is unsteady second order bounded. Now we have our turbulence flag to be false, so it would be laminar. Now, in sometimes during the time I was creating this script, I was not able to find some of these commands like setup models. So the way to overcome this is this command execute TUI, which is terminal user interface. It's very similar if you went into ANSYS Workbench or Fluent, for example, and you can use it to change the properties inside your simulation or setup. For example, in our case, we need to change it into laminars. So you do define models viscous. You do define model viscous, and then we have laminar, and then yes. So this sequence of commands, basically, you are writing them with the space in between to activate this command. So again, if you were not able to find any command inside the Fluent GitHub, or it's not working for any reason, you can use this execute TUI. Here we needed to scale our mesh and making it smaller for some reason. When I opened it inside Fluent, I found it like in the wrong scale, so I just scaled it down. Here we are performing a mesh check. Next, in enabling the energy equation or the advection diffusion one. Again, here we are reading the transient table or the profile file. Next, we are changing the type of the inlet and outlet. ANSYS Fluent by default, when it finds a wall or a boundary named inlet, it changes it into inlet boundary conditions. But just to make sure we are making the correct settings, we are converting into velocity inlet and pressure outlet. Here, we are defining our boundary conditions using execute TUI. So again, what is the difference between this step and this step? In this step, we are changing it from wall into velocity inlet. Here we are assigning the velocity inlet. Next step is to change our units into CGS and assigning our blood density and blood viscosity. And here we are changing the fluid zone into blood because the default is air. And then we do our initialization and we initialize temperature, which is the concentration in our case, to 0. And here we are controlling the time step size. Now we need to export our results. So we are exporting using this extension inside Gold, sorry. This one, you can read it inside ParaView, which we use to post-processing. So if we checked reading DTK insight, reading insight, ParaView, yes. Yeah, I think one of these tutorials were explaining how you can open them. Mostly the first or second one. I don't remember exactly. And also you can check this is tutorials for VTK from our lab. Anyway, you just need to use this extension to save your files. Here we are defining the values you need to save wall shear stress, temperature, velocity, etc. And then you start running for the number of specified time steps using this command. Number of time steps and maximum iteration per step. Again, we are used execute TI, which you can figure out through here by like trial and error. Again, you need to try the specific command which will give you the exact results or the exact sequence you need. And here we are saving our files. And once we are done, the session will exit. Here we are printing the total time. Now we are looping using this for loop for all of our geometry and for each of our profiles. Let's try to run it. And I'll zoom out. We are reading here the first geometry and first profile. Just take a few seconds to start the running and opening the PyFluent. You can see here the ANSYS version. Now, as you can see, it's already started running. You can see here the first file we are reading. One thing to check is basically you are reading your boundary conditions label correctly. So if you didn't find this stuff, blood outlet or blood inlet, then mostly there is something broken in between. You need to double check that. Here is our mesh dimension before scaling. Then we scaled it into the correct one or correct dimensions. You are reading your profile file. There is no warning, there is no errors, and it starts running now. This warning is not very critical inside ANSYS Fluent. And just need to make sure the residual makes sense while running. If you find like these velocities are zeros or it's not changing, that mostly mean either the velocity profile or the concentration one are not reading or like being assigned correctly. And just leave it. You can run it on your cluster and so on. And by that, we are reaching the end of our tutorial and the last tutorial inside our series. Thanks for your time, and we hope that you enjoyed our explanation. And for post-processing your data and working with VTK, you can find the explanation from our lab provided by Dr. Arzani. And feel free to reach out to me through LinkedIn if you have any questions or to Dr. Arzani. Thanks and see you later.